Okay, maybe, no, I did divide. I just don't know how I got.
Are you getting it right this time?
No.
All right, so 3.0.
Mine looks exactly like yours.
3 squared, divide, 2 squared, divide, 1.5.
Okay, 1.5.
That's what I called out, 1.5.
Well, I mean, that's not what I have on paper. I didn't put it all together.
Okay. Now, for Annabelle, number 5. All right, so when you write the equation, first of all, is it balanced? You got Li2CO3 is a solid, goes to Li aqueous plus CO3 -2 aqueous. Is it balanced?
No.
No. You got how many Li's right there?
2.
And you got how many Li's there? So we're going to put a 2 there. Are we good on that? All right, so K equals Li CO3 and over Li2CO3.
Oh, I see what I did there. I put the 2 on the outside of the -2 on the outside.
Oh, okay. Yeah, that's an ion.
Yeah.
Now, Annabelle, look at that equation. Tell me what state you have.
Yes.
That says AQ, not gas.
Aqueous.
Aqueous, and that's a solid. All right, which states cannot stay?
Yes, and it's aqueous.
Those do stay. Which ones cancel out?
Solids and liquids.
So this has to go. All right, so K is equal to Li squared CO3 -2. Okay, those are the only 2 that are staying. So now you plug in numbers and only those. All right, so Li had 0.2 squared and CO3 had a 0.1. Does that help?
But okay, I have a 0.1 and stuff, but it says to the -2nd. Does it not do anything with that?
No, that's its ion. That's part of its formula. It's not an exponent. That is the only thing that is an exponent are coefficients. So unless it is part of this, or this, it does not become an exponent for squaring or cubing or anything.
That would explain what I got 400.
Okay, that makes sense. But does that help you figure out what you did wrong?
Yeah.
Okay. All right. Anybody else have a question? All right, moving on. The last homework page. All right, at the top, question 1. Again, water is a liquid, so it cancels out. You get an answer of K equals 0.087. I rounded off. All right, B, 0.079. Any issues with A or B? Yep. And number 1.
Oh, I see what I did again. I keep using
K
that.
equals H plus, OH minus, H2O. H2O is what state?
Liquid.
It's a liquid. Cancels out. Okay, that's the part Blake couldn't figure out last night and you forgot. It's a liquid, it doesn't stay. So H plus is 0.250 and OH is 0.350. So multiply and you get 0.0875.
And then for the second one, you say you got what?
0.079.
0.079.
This one, they're all gases, so they're staying.
All
All
right.
right, so K equals, you have H2 times O2 as products over H2O.
Oh,
You've got coefficients this time. You balanced. We got a 2 here and a 2 here. Did you do that?
I didn't do products over yet. I was
That'll do it. 0.358. It has to be squared. Oxygen's 0.00125. And then over 0.045 and squared.
And what was the answer again? Sorry.
0.079.
0.079. Okay.
All right, are we there? Yes, no?
Yeah.
All right. And number 2, you're using the reactions that are below the question. I hope everybody found those. And number 2, is it endo or exo? It's endo. Is it positive or negative if it's endo? It's positive. Were we increasing or decreasing in entropy? Decreasing. So is it positive or negative? It's negative. When we calculate, was it positive or negative? It's positive, so it is non-spontaneous. Okay, so you plug into this equation. Delta G equals delta H minus T delta S. You're using your math skills. So we said this was positive for B minus, we said that was we said that was negative in D. All right, so these two multiply. What happens in math class if you multiply a negative and a negative? Okay.
So is that just the standard one?
So these add. So what happens when you add? So if it's positive, is delta G spontaneous or non-spontaneous when you add? Non-spontaneous.
So is that just always a positive minus a negative?
Mm-hmm.
Like always?
If it's non-spontaneous.
Then how do we know what it is when it's not? Like, what is triangle H normally?
That has to do with endo and exo.
Depends
It depends.
on whether it's endo or exo.
Yeah.
You have to figure that out. That's why you have to go through all those parts.
Well, whatever, go ahead.
All right, so in 3, is that reaction at the bottom endo or exo?
Exo.
Okay, so that meant delta H was what?
Negative.
Okay, so we do this again. So delta H is negative. All right, subtract. Now we got to do delta S. Delta S, is it increasing or decreasing if it goes from a solid to aqueous? It's increasing, so is it positive or negative? All right, so these two multiply. What's a negative times a positive? So what happens when you add two negatives? So delta G is negative. Is a negative spontaneous or non-spontaneous? It's spontaneous. Okay, but you have to evaluate that each time. That you just got to flat out memorize it.
You know what? It makes sense. I just didn't hear it from you besides the video, so that kind of.
I got you.
And then
Exo what?
exo is when heat is on the reactive side.
Exo is when heat is on the product side. Exo is when it's released. So heat or energy is a product. Endo is when it's a reactant. It's absorbed. Anybody else?
Entropy was increasing.
Entropy is increasing if it goes from like a solid to a liquid or solid to aqueous or liquid to gas. That's increasing. Now, I cannot think of any reason you need a chart for this quiz. I just can't for the life of me. You should need a calculator.
What if we need a chart?
Then I'll let you get one out. But I cannot think of any reason why you need one.
I don't
Now,
know.
the only people who aren't taking it are the people who tested yesterday.
We're not testing that. We did one from Friday. We made the one from Monday.
What's wrong with Monday?
The one that I thought.
Yeah, we did.
The most. Yeah.
But yes, Patricia, I'll get that for you if you'd like. I mean, there's nothing on it that we did Friday, so you can certainly do that. Yeah. You can come over here. Make sure you write your answers on the line, so I can do that.
This was done with.
Yeah. In A, that is a subscript 3, just a typo. Under NCA and ACL 3, the 3 is not a subscript, it's supposed to be. Good on you. Let's try that again. How many of you are still working? So I'm down to 3. How about now? Nobody? All right. So see, collect the papers. Find your notes. I'm trying to finish this lab paper before I forget where I'm at. All right, let me double check my math. You guys do not need calculators anymore today. You can put them up. Yep.
Bad so far? Oh, that's a lot.
71.
Ew.
No, I haven't done yours. I've only done Raquel's and Caleb's.
I've been at 81 for 28 yesterday.
No, I've done 71 if you turned in yesterday.
I can't even move my legs.
How many have you gotten done? She was there and I wasn't. I was like,
I only got 15 done in 3.5 hours of dance recital practice last night. It takes a while for me to grade these. Because believe it or not, I actually punch in every single number on y'all's paper to make sure it's subtracted right and the calculations are right. And half of y'all either can't copy what y'all have on y'all's lab papers or you can't subtract right because you're going to be surprised. I don't know who Raquel's group is, but 91.1 minus, I think it's 19.1. Might be the wrong number. Anyways, they keep telling me it's 80, whatever the two numbers are, and it's 79. I've punched in like 8 times. I'm like, surely this math is not wrong. And it is. They're off by a degree. So both of you have lost 2 points in your calculations because you subtracted wrong. Okay? I mean, it's little stuff that's eating you guys up on your lab papers. Groups have lost points all the way through the data table. Not a unit to be found. Some of you have 2 places behind the decimal in your temperatures. How many places go behind the temperature? 1. Some of y'all have no places behind the decimals in the temperatures. Significant digits are wrong all over the place in calculations. That's a jacked up mess. Okay? The calculations for showing work, some of y'all didn't show work. Most of you did. Some of you did not write a complete sentence or show questions. Caleb, you got nailed because you didn't follow the format. You didn't write name, date, title, purpose, procedure, any of the titles anywhere in the lab. So you lost points for every single one of those. I mean, so you got hammered on that plus the minus 10 for being late. So you probably lost, just guessing, 18 points right there. So, you know, if you had the 10 points plus that, your lab grade would have probably been at 90. Just did what you got wrong, you probably had 90. Okay? So throw in all that just extra junk that you lost there, would have been that.
He's in.
I mean, it's just format stuff. So, I mean, if you guys could fix that, y'all's grades would be so much better. But it's the format stuff that's killing it. So when you guys go to school somewhere, if you have to take a lab class, the lab class that you have and the professor you have will want it done a certain way. It won't be my way. Okay, it'll be their way. So when they tell you to follow this format, follow it. Okay? If you take an AP class from Miss Thornhill, she'll have a way she wants it done. Follow it. Okay? Now, remember LeChatliers?
No.
Okay, we're going to do LeChatliers today. I will be stunned speechless if you do not see LeChatliers somewhere on your exam in those 45 questions. Okay? This is not the most fun topic in the world. Annabelle's going to really hate me after this one. Okay? We're going to talk about shifting. Okay? If you didn't like the math, probably not going to like this any better. All right? So according to LeChatliers, we can shift to establish or reestablish equilibrium. We've already written down the definition for him, so I'm pretty sure I didn't rewrite it, but I may have. Yeah, I did. Okay? I don't care if you write it, you've already got it in your notes. But I put it up here in case you forgot. So, if a system is at equilibrium, okay, if we add stress, the system will readjust to minimize that stress. Okay? So, we're going to have a system that's already going to be in equilibrium. And we're going to do something to stress it. Does anybody remember the 3 stresses I said we were going to have?
Temperature.
Just one? No, you are not going to cause the stress. You only stress me.
Surface area.
All right, not area. No. Temperature's 1. Nope.
P.
Starts with P. Pressure. So that's the pressure.
And then coach.
Concentration.
I know y'all heard me say concentration over here.
That would be right. Justin. All right, temperature, pressure, and concentration are the 3. I usually start with concentration, and everybody tells me after I do it as well that was the hardest of the 3. So we're going to put it last this year, okay? So I'll just skip around in the notes and make him last. All right? I'll either do temperature or pressure first. I think we're going to try pressure first this year, okay? Y'all are good at moles, so we're going to do that one first, okay? All right? Because you just have to count moles. Y'all are good at counting, okay? You have been so... Really? 2, 3, 4. We're not going high here. Okay? Some of them might even have the same number of moles. Does everybody have what they want if they were writing?
Yeah.
Okay. So, y'all already told me that. So, the 3 ways we can shift equilibrium are either pressure, temperature, or concentration. Now, beside pressure, I did put we can change volume. Does anybody remember? Probably not, but let's give it a shot. Which law pressure and volume were? Very good. Wall's law. How are pressure and volume related? Okay, look. It's my man back there. Okay?
You were just
I told you had all the answers right. This is format is killing me. And ask him why I lost 10 points.
Very late.
Yeah, but why?
Why is it late?
I left my notebook in here one day I stayed after and I had all my information in there.
This wall.
I don't know where he lived. I couldn't take it to him.
You could have
I mean, you could
called.
call.
Right.
You could have been like, hey, you left your
You got records.
You know, he gets a plus.
I could have driven all the way out there and taken his stuff. Right.
You could have taken an Ocean View. You know he works there. You always complain.
Right where Ocean View is. Where's Ocean View?
It's on Highway 8.
Oh,
I didn't know where Country Road. I've never heard of it.
okay. I was thinking it was in Salisbury, so okay.
You would have been lost.
Is there one in Salisbury?
No, but they look the same.
It's got a waterfall.
Why are you putting that on your head?
Yes, that's
Take that off.
all.
You don't want to have this whole class
What's
period.
that word?
What is wrong? Anyway, she's just against you today. It is. God almighty.
This girl will probably walk in and jump on me because you wearing that.
I've been wearing it.
Oh, wait,
since
which
freshman
one?
year.
Senior prank?
Huh?
They're right there.
Hey, Devin.
Did you like it? Did you think it was amusing?
No, they were like spraying the water
Yeah.
hose like in the
It was
classroom.
power washing.
Right. I was like,
All right.
I
So,
was scared if I was in class. but
so
they
what was
would've
the
told me.
relationship between pressure and volume?
They're what's it called?
They're what?
What's the opposite?
All right. You said Boyle's law.
Is that the one where you multiply it? Okay, yeah.
All I want is the relationship.
Yeah, that.
They're either inversely or directly. We got the two. They're what?
Inversely.
They're inversely proportional. That's good. We knew it was one of them. We got it narrowed down to a 50-50 shot. That's good. So inversely means what again? Opposite. One goes up, the other goes down. So they might not say something like, if we increase pressure in the question, they might say they did what to volume? Okay, I heard it over there. So instead of saying we increase pressure, it's the same thing as saying we do what to volume? We decrease the volume. That would be the same thing, okay? Now, I think, just a guess on my part, they would lean towards saying they increase the pressure or decrease the pressure, but if they wanted to combine two concepts in the same question, they could say something about volume to bring in Boyle's law into LeChatliers, okay? They could do that. So I'm just pointing that out. No, you will not need to know Boyle's or Charles or Gay-Lussac. You just need to know that pressure and volume are inversely proportional. Okay? All right, let's see where I have it. All right, that's concentration. We're jumping over that one. Okay, pressure's where we're going. All right, so there are two rules. Okay? No way to fix the rules, you just have to learn. Now, the bold parts are the rule. Okay? The non-bolded parts are sort of the reason or explanation. All right? So those of you, like Annabelle, who just need the rules, don't want to know the reasons, you only need the bold parts. Okay? Those of you who like to know more about the reasons, like Raquel, you need the non-bolded parts also. All right? So if we increase pressure on a system that is at equilibrium, okay, the system will shift in a direction to decrease the pressure. It's trying to get back to equilibrium. All right? So if we increase the pressure, it shifts in a direction to decrease or lower the pressure. Well, the lower pressure will be on the side that has fewer moles. Want to fix something that's bothering my OCD.
Yeah.
Girl, you'll miss I think we got more than
So you're saying I was about to get all the way up there?
Yep, it was.
Yes,
That's what that OCD.
let's think of my paper on this.
Huh? I couldn't keep working with that.
the person that can't staple paper and stuff. I can't even say
All
that
right.
because you stapled the mess.
So the flip side of that would be if we decrease pressure.
Oh my.
All right? So again, if we're at equilibrium and we decrease the pressure, what will the system do if we decrease the pressure? That's right. It has to shift in a way that will increase or bring the pressure back up. Well, how does it bring the pressure back up? It shifts to the side that has more moles. Okay? All right, we caught up?
No.
And you left with that.
We there now?
Yeah.
All right. So aside from being able to decide left or right, you're also going to have to be able to figure out what happens to the concentration of the reactants. All right? What did I tell you the brackets meant? Concentration. All right. Now, this is not unique to pressure. Okay? Did everybody hear me say this? This is not unique to pressure. This will be true for any of the shifting we do today. If we determine that it shifts to the right, okay, meaning it goes this direction, what's going to happen to the concentration of the products? Will the concentration of the products increase or will they decrease? They will increase. Okay? The concentration of the products will increase. Okay? So, if the products increase, what will happen to the reactants? They will what? They'll decrease. Now, Kevin, hush. The flip side of that is shifting left. So what happens when we shift to the left? That's right. Anytime we shift to the left, the reactants will increase, and the products will do what? That's right. The products will decrease. Because we're not just going to figure out right and left today. We're also going to figure out who increases and who decreases. This rule that we just wrote down does not change all day today. Okay? It's true for pressure, temperature, and concentration. If it shifts to the right, whatever's on the right will do what? Increase. If it shifts to the left, whatever's on the left will do what? Increase. Okay? Whichever direction it goes will increase. Does that make sense? Okay. Does everybody have what they need? All right, so let's talk about pressure. All right, so I wrote an equation. I gave you the NH3 equation again. There's your other arrow.
I'm trying to see that equation.
Can you blow that up a little bit?
Sure.
Just a little, not too big.
How's that?
So I was supposed to know which way to drew another arrow.
Oh, I only drew another arrow, so it's the equilibrium. It's the reversible arrows.
They are loud.
It's
You
the
think that got,
yeah, and Raven.
Is that and Raven?
Cynthia, just go close the door.
It's supposed to be an ISS.
The lesson in this is
So we're
apparently you get
Yeah,
in
I know,
trouble
like,
and you
that's
get to
what
roam the
that's
building
supposed
and
to
cut
be
up.
ISS room.
Right.
Oh, I have to.
Probably shouldn't say that live on YouTube.
Oh. We didn't miss Wall. We were just JK.
It was just a
Hello.
joke. No.
Maybe not when we graduate. Don't be so sensitive.
All right, so if this system is at equilibrium, okay? Remember, the question will always tell you you're at equilibrium. And then it's going to tell you something about your increase of the pressure. All right? So, I want to know I want to know which direction will it shift and what will happen to the concentration of NH3 and what will happen to the concentration of N2.
What is the volume talking about?
Oh, so what would happen to the volume? If I increase the pressure, what would happen to the volume? Right. Okay, that's the same as them saying that volume would decrease. All right, so applying your rule. What did I say was going to happen to the pressure? We're increasing it, right? So what does the rule say?
Whoa.
If I increase the pressure, it does what? Decide a fewer moles. All right, so if I increase the pressure, the rule says side fewer moles. Okay, so we need to examine the moles, right? Rosanna was worried about my moles, right? She said, I need a calculator. No, you don't.
You didn't need to look at the coefficients.
All right, we're looking at the coefficients, right, Rosanna? So, tell me how many I got right here.
1. Oh, you saying over there?
Yeah, 1.
Oh,
How many here?
3. You got 3 there.
So how many I got?
You got 3, right?
Yes, I got how many here.
Oh, you got 4 there.
Okay. I was worried for a moment. I was going to get you a calculator. All right. And how many do I have on the product side?
2.
Okay. Yeah, but you recovered. You recovered. So we go from 4 moles to 2 moles. That's what we have. All right. So which side has fewer moles? The reactant side or the product side? The product side. So are we going to shift to the left or to the right?
To the left.
Go shift left. I'm sorry. I listen to y'all so much, even I don't know my left from my right anymore.
Right.
I don't know why I said left.
All right. So are we shifting left or right?
Right.
Okay.
I was so confident. I was like,
Left.
All right. We're going to the right. Now, what other way can we say to the right? We can also say forward. Okay. The forward reaction, okay, is that way. The reverse reaction is that way. And sometimes questions like to use forward and reverse. Okay, so right or forward. Now, if it goes to the right, what is going to happen to my concentration of NH3? Will it increase or decrease? It will increase. This is why we wrote this down. Anytime it shifts to the right, what happens to our products? They increase. Okay? So, NH3 will increase. So, if it goes to the right, what happens to our reactants? They decrease. That rule never changes. You with me?
Yeah.
Okay. Now, okay. So I want to know the direction of shift and the concentration of I2. Sorry, I. H-I. Yeah, 2 arrows. We wrote the other one up there. All right. So if I decrease pressure, what do we know?
Volume increase.
Increase volume.
It does increase volume. Okay, that's good. Okay. It's not overly important for our question, but that's good that you know that.
That's the other thing.
To be honest, it will shift to the side of more moles.
Okay, we'll go to the side of more moles. So the rule is more moles.
Oh, they're equal.
Okay, so it goes to the side of more moles. And I have several people yelling at me that it has the same number of moles. So let's double check it, make sure we all agree with them. All right, so how many moles are on this side? 1 plus 1 is 2 moles on this side. All right, and we have 2 moles on this side. So do we all agree with them?
Yeah.
So if we have the same number of moles, does it have any effect?
No.
So there is no effect. So what happens to the concentration? Stays the same. There's no change.
So this would be like no solution.
Yes. And pressure is the only thing that will do that. Okay? Pressure is the only one that will do that. Temperature and concentration cannot have an answer of no change or no effect. Did everybody hear me say that? Okay. Temperature and concentration cannot have an answer of no effect or no change.
Did you say temperature or pressure?
Temperature and concentration cannot have an answer of no effect or no change. Only pressure can. Okay? Because it depends on moles. And only pressure is going to have moles in it. Of no effect or no change. Yeah.
You said only pressure.
Only pressure can have that answer. All right. Everybody got what they want? Of course y'all are.
That's your family. But we have to balance it.
Did I balance it?
No.
I just didn't walk into school. I didn't see him like going to my class.
There's another example.
Is it another example? Does it look like the same example we just did? Then yes, it's another example.
Because we're missing the love people. Except for Angela, she should be. Nobody loves putting No, Nadia and Alondra.
Yeah, Nadia, Alondra, Nakaya, Faith, Alejandra. Am I missing anybody else? I haven't done the attendance yet.
Sarah Lynn.
Sarah Lynn, yeah.
She's absent. I thought she came in the class.
She did. They called her right at the beginning of the class. All right, everybody got it?
What do you mean decrease?
Decrease pressure. All right, so what's the rule?
Fewer moles.
Fewer moles. All right, so fewer moles. So what's the first thing I need to check? Is it balanced?
No.
No, it's not.
You put a 2.
Now, if I was a betting woman, I would say it'll be balanced on the exam. Okay? So if you don't see coefficients, double check. All right, so when you look at it, how many moles are on the left? 3 moles. How many moles are on the right?
I thought it would be.
Yeah, I thought it would be more mold. It's more mold.
Oh, did I write? It is more.
Sorry.
Oh.
Thank you. All right. When you decrease, it goes inside of more moles. I just wrote it because y'all said it. I really should stop and think some days.
Yeah.
All right. Let me write left and right up here before I'm listening to y'all when y'all yell out left and right. All right. So if we decrease the pressure, it has to go to the side of more moles. What side has more moles? To the left. Okay? Or reverse. Either way is correct. So if we go to the reverse, what happens to our CO concentration?
Decrease.
It increases. All right. And what happens to CO2?
It decreases.
It decreases.
I get. Hey, this is easy.
Yeah, I like that.
You got it?
You're basically just looking at the mark.
Once you figure out more and left,
Oh.
you're just looking at that. Yes. Okay? Now we're going to do temperature next. I told you, we'll save concentration for last.
Oh, we gotta do all three?
Yeah.
Why?
Today?
I don't know which one will be on the exam. It could be all three of them.
Oh.
Or 9. Do you think we're all
You-
gonna pass?
I would almost guarantee you're going to see this one.
Okay.
I'll be shocked if it's not
Higher
there.
than a 70 for the majority.
Say what?
Higher than a 70.
Um,
Like at
I mean,
least
there's just nothing I can do to bring my grade up.
What's your grade for that?
honestly, I'm hoping for better than 80 for 85% of y'all.
Stop.
Okay.
I'm for real.
Well, I was still
I thought I did so good last time when I got a 47, so we're just be
I
honest.
seen the memes and.
All right, so find me an answer. All right, if we were write the rule down. Hello, Karen. What may we do for? Oh yeah, y'all are the psych folks.
Yeah.
I thought that was next week. Maybe we're already on this week. I don't remember what day Miss Love was here. All right, so if we remove heat, all right, the reaction of equilibrium will go in the direction to produce or make more heat. Essentially, it goes to the warmer side. Now, here's a cheat for you. Okay? Just for Annabelle, so she likes this. Okay? Is the side with the heat or the energy on it. Okay? I can't make it any easier than that. It's going to go to the side with the heat or the energy.
Produce heat. How does that make sense?
Mark out one of them. To produce heat.
Put an or in there.
Excellent.
Or.
Oh. Really put a line.
Okay? So for those of you who just want the rule and don't want the reason, if you remove heat, you have to go to the side that is warmer. You have to go to the side that has the heat or the energy on it. Okay? Whatever side that happens to be on. So the flip side of the rule is, and I'm pretty sure this is the one I forgot to bold. It is. All right. So, if you have to shift to the colder side, this one will be the side without the heat or the energy. What is wrong over there, Joyce?
She threw my notebook on the floor.
Why?
I don't know. She making fun of me. She grabbed my notebook and just threw it. Oh, Karen is witness.
Go ahead.
Colder. What is colder?
Thank you.
All right, I don't think we need any of that.
Really, Miss Laura?
I was looking to see what it said.
Are you studying us? Are you wanting to know how we're doing in this class? I'm failing and I'm impressed.
Oh, where's your light?
In the pouch. All right, we caught up?
No.
All right, does everybody have it?
No.
Who's still yelling no?
Laser Brown.
Why are you doing that? Okay, I'm ready.
All right, so we've been working with equations like out of my lunchbox.
I was never in your lunchbox.
It's only a matter of time.
I was about to, but I didn't. Because you would make me mad.
All right. So what side is the heat on?
Right.
It's on the right. This right here is our heat. Right?
Right.
So this would be the warm side. And this would be the cold side. Everybody okay with that?
You don't give me a second right now.
Right.
Right. Do we really need to know like all the HVAC?
No, but they're going to be in the equation. Come Monday, you're going to be responsible for writing in the states on every single thing in the equation.
Oh.
Okay? Come Monday. We're going back to writing some equations. And come Monday, you have to write the states on everything in the equation. States such as solid, liquid, gas, and aqueous. You've learned everything on the periodic table. So you should be able to write solid, liquid, gas for elements. And I'm going to teach you the rest. The only chart we have left to read is solubility on our reference table. We're going to learn how to do it Friday and Monday. That's where the next lab comes from.
Week.
Okay?
The longest week ever.
Yeah.
I'm so glad.
And it is.
Shush.
No, you know what?
Now,
I thought about you this morning. You want to know what? I had my stats.
Wait, how was the number 6 again?
just for Annabelle?
Yeah.
That's so nice of you, Joyce.
I know, and I also brought
Oh, Mom.
these because I knew she would ask me for these.
That is so nice.
She hasn't explained.
Give it to her.
All right. Yes, Kevin. What, Kevin? What?
How do we tell the states?
I said I'm going to show you that late this week, Friday and Monday.
Chill out.
Right now, you don't know.
Oh, here got me thinking.
All right. We know all that. We don't need to do it. All right. All right. Now the psych people are stealing food.
She got good dog biscuits in her lunchbox.
You know, Denori believe those are real dog biscuits. Denori.
Oh,
He believed they were dog biscuits. Now he's just convinced white people eat the weirdest foods because they taste bad.
Have you left them little peas, whatever the uncooked peas were?
Right.
Have you left them?
Good law. I'm just, you don't be eating it this class.
Y'all made enough fun of me. I finally just stopped.
They're not good for you.
Well, is that the heat?
It's what?
That number, the heat
Yes.
for it?
They're
Now,
They're
sometimes,
fried. It's freezing.
Can we close that door?
sometimes, instead of writing heat or energy, they will give you a number, and this is the heat. And I varied it because I do not know which way you'll see it on the exam. So I'm trying to give you every variation I can think of before you take the exam.
So if the unit is on it, that also means the heat.
Yes, that's kilojoules per mole.
Well, I'm not that.
What is wrong over there, Karen?
It's cold.
It's cold air conditioning.
That's what they're trying to figure out because she thought it was coming from like that room.
These squares that are above your head are the exhaust fans that are this.
Don't do it.
Okay?
No,
It's not on. I just turned it off. Okay?
That's live.
These
It's been
are the vents that blow the air out. The squares in the middle are the return vents for central air. The vents that are over there are the exhaust fans. Okay?
Why is it cold?
Why we got 3 different?
I do not know the answer. Huh?
What are those?
Those blow air out. Those suck air in.
Are those and those?
Yeah.
Out, in. Out, in. Those are not on unless I turn on the exhaust fans.
Hitting me.
Alright? Now, if we add heat, alright, we still want to know the direction of shift. And let's say I want to know what happens to O2 and what happens to the concentration of water. Okay? So, what happens if I add heat? What is the rule?
You're gonna shift it.
To what? Moles have nothing to do with heat.
Oh, just one with peanut
Okay.
butter.
Go to the warmer side.
The rule is it goes to what?
The
Colder side.
You're shifting reverse.
Okay? So the colder side is the one that doesn't have the what?
Heat.
Doesn't have the energy or the heat on it.
The word, the letter.
The word or the letters or the number. Okay? So if I add heat, the rule is it goes to the colder side. So which one of these does not have the word, the numbers, or whatever? All right, let me write Eleanor up here for you people again.
Reverse it.
Okay, it goes to the left or the reverse. So if it goes to the left or the reverse, what happens to O2? It increases. What happens to H2O? It decreases. Okay? Yes, concentration is the brackets. Shorthand. All right, so let's make up another problem. Oh, I gotta leave it.
You don't care anyway, go.
You're moving too fast today.
Yeah, it's the same equation, it's just the opposite. So,
Okay,
Never ask us for both.
in the same equation? No, because it's just the opposite. Yes.
Will there ever be like the time we have to put numbers or changes in there?
No, because the state doesn't want you to actually calculate with that. They just want you to be able to do it conceptually. It would be easier if y'all had to calculate. All right, so let's say that we have energy plus I2 plus H2 goes to HI. And let's say that we decrease temperature. I want to know the direction of shift, and we want to know what happens to H2 and HI.
Thank you, Ms.
Welcome.
My class.
All right. They're doing something for psych. All right, so when you look at the question, all right, there's your equation. We're going to decrease the temperature. We want to figure out which way it goes. And then we want to know what H2.
To the right.
Okay, hold on. Let's not just assume automatically to the right.
Miss Plum.
What?
Can we write it first?
Yeah, that's why I said let's not just automatically assume.
Oh, it's on to the left.
All right, now here to the left. Hold on a second, let people write.
When you say question mark, we're talking about something like this.
Yeah.
Yeah.
All right, so if we look at the rule, what's the rule for decreasing temperature? Where does it go?
To the warmer side.
All right, so it has to go to the warmer side. That's the rule. All right, so the warmer side is the side with the what?
With the energy.
That's right, the side with the number or the energy.
To the left.
So, which side has that?
Left.
Energy left.
Reverse.
Okay, to the left or reverse? Okay, everybody with me on that?
Wait.
No,
All right. Yes or no?
I thought if it was with it, then that means it's going to the other side. So whichever one it is, that's the way it's shifted.
Oh, so does the H2?
All right. So H2 will do what? And HI will. Yep. Got it?
Yeah.
All right. Last one. Concentration.
I can make it on Friday.
Yeah, Plickers I didn't expect to get to.
Oh, we're getting to it?
No.
No.
I've got it loaded for tomorrow, but we probably won't get to it till tomorrow. All right. So we can do two things with concentration. We can either add it or remove it. So the first rule is to add. We can either add a reactant or product, or we can take it away. So if we add a reactant or product, it will shift to the side to use it up, which means it shifts to the opposite side you added it to. All right, so if you add something, you have to use it up. So it shifts to the opposite side that you added it to.
You do a 3-minute break, start.
So if you add, it has to go to the opposite side. So the opposite of that is to remove. So if you remove a reactant or product, you have to make more of it. So if you remove a reactant or a product, it will shift to the side to make more. So it has to shift to the side you removed it from, or you could say the same side. All right, so if you add, it has to go to the opposite side. And if you remove, it has to go to the same side. The hardest part for most people about this is usually remembering the rules. All right, am I still waiting on people to write?
Yes.
I only have a little. Yeah, everybody from the beginning.
Anybody else?
Yes.
What did you take, a slow pill this last paragraph?
You don't?
No, I finished my goal stage.
Oh, good Lord.
So how about you, Lisa?
Okay, I'm good for sure.
All right, everybody there? All right. So these questions are all different. This is the nice part about concentration. It's easier to vary these questions because I can do lots of things in the question. So if I add oxygen, all right, I need to know the direction of shift. And I want to know what happens to nitrogen. If I remove nitrogen, I want to know the direction of shift, and I want to know what happens to oxygen. If I remove NO, I want to know the direction of shift, and let's say what happens to N2 again. And I'll label that as L and R.
Give me a minute.
You awake, Caleb?
Okay.
Come back. Outside the windows, come back in here. Summer break is coming.
No. Like, I'm so miserable right now, but in 12 days for me at least, it's all gonna be over. And think about that.
Right.
It's gonna be
Don't be
amazing.
lying. Don't be lying.
Almost there.
But then I'm just gonna be grounded for life because of your class because I failed it. So.
Hey, my grade's now lower than White's.
No,
See, why are you complaining
no,
this?
my grade in math is higher than this, like
That is-
a whole 8 points.
That is.
That's so sad.
I know, because freaking lab brought it down.
My lab did not bring your grade down 8 points, so stop whining about 8
Brought
points.
it down 2.5, so basically 3.
Alright, so if we look at oxygen,
Miss Wall, I just now thought about it. You were supposed to take homework today. But it's cool. I'm just saying.
so if we add oxygen, the rule is it does what?
Goes to the
Goes to the
opposite side.
Goes to the opposite side. So oxygen is a reactant, so that means it has to go to the what? Has to go to the products. So that means it's going which way?
Right.
To the right
Forward.
or forward. Okay, that's the hard part about doing this. You have to look at where oxygen is in the reaction. It's a reactant, so it goes towards the products. Is everybody okay with that process?
Yeah.
I'm
Okay.
just gonna have to keep doing it because I really don't know.
That's the hard part about concentration. That's why everybody every year tells me don't do that one first. Okay? So oxygen is a what?
Gas.
Is it a reactant or a product? I don't care if it's a gas.
Reacting.
It's a reactant. So if it's a reactant, it goes to a what? To a product. So remember, the rule is it goes to the opposite side when you add. So if it's a reactant, it has to go to the opposite side, which is a what? Product. That's why it goes to the right. Because the opposite side from the reactant is the product, so that's the right. So will N2 increase or decrease?
And now, how do you that part?
Yeah.
Where's N2 at? It's a reactant, so if it goes that way, remember, anytime it goes this way, that will increase. This will do what? That will decrease. So this is going to do what? It's going to decrease.
So why you draw that if it's
Anything that's on the left will decrease, and whatever's on the right will increase, because you said it's going to the right.
I thought yeah.
Now, forget everything we just did. Next question. None of this applies. Okay?
We're removing nitrogen, so the rule is same side.
Okay? Now, we're going to remove nitrogen.
It'll stay on.
What's the rule for removing?
It'll stay on the side.
Same side.
Ah.
Okay, so nitrogen is where?
Left.
It's on the left. So it's going to stay on the
Left. Reverse.
So what will happen to O2 if it goes to the left? What happens on the left?
Decrease. Duff.
Every time it goes left, what happens on the left?
Increase.
That's right. Where is
Oh, that's right.
oxygen in the equation?
Don't put that eye there. Don't put that eye there because it looks like you're going to the increase.
Right, that's all we
It is increasing.
Whatever side it shifts to increase.
Yes, whatever side it shifts to increases.
Wait a minute, let me write that
Absolutely
down.
no sense.
So if it shifts to the left side will increase.
Right.
And since oxygen's
Okay, if it shifts
No
right,
sense.
that's what Destiny just said. If it shifts to the right, it increases. If it shifts to the left, it increases.
Because that's what side is moving to.
Yes,
Right?
correct. That's what she just said. That's just a picture of what she said.
I don't like that picture.
Then don't use the picture.
Whatever side.
Okay. Whatever side it shifts to increases. Okay? So forget everything we just wrote down right here. Last question. So if we remove NO, what's the rule for remove NO? Same side. All right, so what side?
Forward, right.
What side is NO on? It's on the right. So I heard
Forward.
forward is good. I heard right. That's good.
And it's gonna increase.
So I asked about M2. If it goes to the right, what happens to M2?
Increase.
What? Y'all be so stupid. This
You
is
gonna give us
stupid.
homework?
Yes. If it goes to the right, this will do what? You said whatever side it shifts to, Destiny, it does what? It increases. So that's going to increase. That means this will decrease and this will decrease. Because whatever side it shifts to will increase. So that increases and these two decrease.
What's homework?
Find last night's homework. It has a back side. Ooh.
Wanna do it right now?
Find the whole back side.
I am
This,
so.
is it?
The whole backside? That chart? The whole thing?
My entire.
Well, you.
Now I understand.
I'm going to borrow Linda's for 2 seconds. You don't have calculators, put up and stop whining.
I'm so cold and ready to leave.
Y'all need to bring a jacket to class.
I have
Something bigger. If y'all are that cold, what do you want me to do about it? Come on, Ladybug, wake your butt up. Come on.
Okay, what I mean.
Don't turn it off completely, bro. At least put it on low.
It probably only feels cold.
All right, when you look at this thing, the only column you don't have to fill out is this last column, because what are you supposed to know about K? What's the only thing that makes K change that we talked about yesterday? Anybody remember?
No, because I wasn't here.
I wasn't asking you that, but you need to watch the video and find out, because if we have a quiz on it tomorrow, you're responsible for it. What's the only thing that makes K change? Temperature. So you're going to write remains the same for everything except what? Temperature. Now, you don't have to know how temperature makes a change, but you need to know that it will change for temperature. Okay? You could just write it will change. Okay? Now, why are there blank spots right here beside M2?
Because that's add into.
It said add into. You're not going to put an answer here where the lines are. Okay? When you get down there to temperature and pressure, you got to have something in every blank.
Oh,
Every spot has an answer.
Beyond me. Beyond me.
Jasmine Wilhite, Takaya Winston, and Life Jim, please come to the main office.
Why are you knocking?
I thought the door was locked. It didn't move. It's like, hey, Kira. Here, can I borrow you? Yeah. You went to the spring concert this fall?
I didn't know about it.
I would love to.
Liz?
What did you have Saturday night?
Dancing like
This is tech week for us.
Okay, never mind. No, like, yeah, I guess.
I won't. Last night we got home at 9:30, and Thursday night is longer.
I
So,
understand. Why don't you just come here during lunch? Okay.
I wish I could.
No, Miss Wall, I completely get it. You're in the world of glitter and alterations and making sure that your daughter's dance shoes fit, like all that. I get it.
Yeah.
I like to shop.
Not next year. The following year, I will be able to come to the spring concert. It's gonna be done.
Yeah, it's all good. But tell Shelby to break a leg.
I will.
You mind if I?
That's why I make you put it there, so that if you want it, you can have it, or whoever beats you to it. It's usually you.
3 hours.
For no reason.
Brother Heckers. You got a lab today?
What's up?
I got stuck. Apparently, apparently, I guess they have some sort of meeting, some uncalled meeting. I don't know if it was about that or whatever. So, yeah, he texts me. I was like, please. This more texts me. What's your intention? Please call her later. Either not something like that. So apparently, I guess they don't need a lot of license. I guess Harvey's was doing it during so they could do that meeting. So, now I'm coming there.
Yeah, they were.
So yeah, I said, you're not chill. But then they got mad at the end here because Harvey came in and we're talking about the issue and stuff and kind of get a little in the hall. Started a bit. So,
I've heard that.
Her name was he's he called it that and takes up a lot of time.
He does.
Yeah, so, That's not so she just, gets me so then exactly already. And she was mad at the Ebony. It's like, well, you're the smarter of the two. They don't actually she's not.
Because
They're nice. Do what?
I need to stop the video.
They're